This lesson is about using congruent triangles, given the fact that once we know two triangles are congruent, we know that all their corresponding parts are congruent. Since the premise of this lesson is that we can use two congruent triangles to prove that corresponding parts of them are congruent, we're going to be using the acronym CPC-TC, which we've learned in previous lessons, stands for corresponding parts of congruent triangles are congruent. Now this can be used as a reason in a proof. Once you've proved that two triangles are congruent, it would be the next step. And you can also just write in your own words, when two triangles are congruent, their corresponding parts are congruent, and that's the same thing. Okay, let's do a few proofs as an example. In this first one we have, looks like two triangles here joined with a common side. And the first I put the givens in already right into the proof, and what we're supposed to prove down at the bottom, and we'll just fill in. So I've got that segment PR bisects angle QPS. So that would mean that this angle and this angle are congruent to each other. So I'm going to write that in here, that angle QPR is congruent to angle SPR. And the reason for that is that that's the angle bisector definition. Okay, the second thing that I'm given is that segment PQ is congruent to segment PS. So that's this segment to this segment. And now what I've got to prove is that Q, this angle right here at Q, at that angle, and this angle are congruent. So if I can prove both of these two triangles are congruent, now I can say that their corresponding parts, Q and S, would be congruent. So my last thing I'm going to need, I've got a side angle congruent to a side angle, is I need a side, and I've got this common side right here that is in both triangles. So I can say that PR is congruent to itself, and that would be, of course, reflexive property. And then I've got those two triangles congruent. So that's a key thing that I'm doing here, is I'm trying to prove the triangle's congruent. So triangle, let's go QPR is congruent to, and that would correspond to SPR. Okay, and the postulate that I use to get that is side angle side. And the reason that I proved the two triangles congruent is now, step 5, I'm done here. I can say angle Q must be congruent to angle S because they are corresponding parts of two triangles that I've just proved to be congruent. So corresponding parts of congruent triangles are congruent. So this step is always going to follow, a statement where you've just proved two triangles congruent using one of the three postulates, side angle side, side side side, or angle side angle. And that's how you use it. Okay, in this next example, we have two back-to-back triangles here with a common side that they're sharing, and we are supposed to prove that M is the midpoint of JK. So I'm just going to kind of circle that. So remember, that's my goal. Now, I'm going to prove M is the midpoint of JK. In order to do that, I'm going to need to prove that JM is congruent to MK. So maybe I can do that by proving if these two triangles are congruent, that those parts, JM and MK, will be congruent to each other. So let's look at what I'm given. Angle 1 is congruent to angle 2, and angle 3 up here is congruent to angle 4. So I'm almost got those triangles congruent. I've got two angles, and if I pick up the included side down the middle, I'll have a congruent triangle. So let's say that LM, segment LM, is congruent to itself by reflexive property. And then I've got congruent triangles. So let's see, triangle LMJ. I'll do it in that order. Is going to be congruent to triangle LMK. And that would be by angle side angle postulate. Okay, now that I've got those two triangles congruent, remember earlier I said I had to establish that that J, M, and MK were congruent? Well, I can now say they are because they're corresponding parts of two triangles I've just proved congruent. So segment JM is congruent to segment MK because of they are corresponding parts of congruent triangles, and therefore they are congruent. And I'm pretty much done now, because if those two are equal, M must be the midpoint of JK, and the reason for that is the midpoint definition. So that's it for how to use corresponding parts of congruent triangles, the fact that they're congruent, to prove other parts of triangles congruent. And we can further use other parts to prove lines parallel, or prove that segments are bisectors, or that points are midpoints. So that's it.